All right, thank you, everybody. Can everyone hear me okay? It's very strange. I've never done this sort of presentation before. But yeah, I'm Jason O'Connell, so I'm from Macquarie Bank in Australia. Basically, that's a retail bank. Some of you might be familiar with Macquarie Group. It's a global organization. But Macquarie Bank itself is just an Australian retail bank. So what I want to talk to you about today is Kubernetes and site reliability engineering. We've been using Kubernetes quite early on, so we've been in production for 2 years now, so relatively early adopters of Kubernetes. So just to give you a bit of context, Macquarie has no branches, so we're a digital first bank. This gives us a lot of agility, but it does mean that our engagement with the customer by our digital channels is critically important to our success. This is just a screenshot of my account here, just to give you an idea of some of the features we've got. So we've got transaction categorization, we've got transaction search, geolocation tagging, budgeting. It's a nice site, yeah. I think there's a few Australians in the audience, so if you're in Australia, you can sign up for it. This is the mobile app here. We've got a lot of features, say, around planning trips and trip management. So when I arrived in the States, it explains to me that I'm in the States and the cards I can use and get support. This is just an example of natural language search. So I can search for, in this case, transactions around Chatswood this year. Chatswood's a suburb in Sydney. And I'm just going to see all my transactions this year listed by category, etc. So there's a lot of nice things you can do in terms of searching for your transactions. We also do geo-tagging of your transactions. So if I drill into a transaction, you can see here that you can see the location of the transaction, and also you notice I've got an attachment on the transaction. So it's pretty common that you'll use your credit card, get a push notification, you can elect to take a photo of the receipt or anything you want and attach it immediately. There's a lot of nice features. That just gives you a context of what we do. And so because our digital engagement is so important for our customers, we've kind of got a nice separation here between our product and feature teams that are building these customer-centered features versus our platform teams such as mine that are enabling the product teams to move forward. And so really the separation is very important, because what it means is that a team like mine, I run a Kubernetes platform for 50 teams, about 400 applications are on the platform, hundreds of developers use it. But we don't just offer Kubernetes alone, we also build services on top of that. We put in things like HashiCorp Vault for secrets. We've got Open Policy Agent for policy management. We've got an Envoy proxy for micro gateway. We also write all of the deployment and release automation too. And the idea of that is we've got some very nice ways, which I'll show you about how we do releases, that now we can have 50 teams sharing these ways of doing things. And then more relevant for this talk is how we manage SRE tooling as an offering for all of those teams. So if you think of site reliability, performance and resiliency as the #1 customer feature, it's important that we give the product teams everything they need to enable that. And so just what I'm going to talk to you about, I've broken up monitoring, how I see it, into 3 categories: runtime, review time, and release time. So our runtime monitoring is the bread and butter of monitoring. This is everything looking at what's happening in the systems right now. So current state. This is where basically we're looking at latency and errors on all of our applications. So in terms of runtime monitoring, I want to talk to you about how you can test your monitoring. You built a lot of monitoring and alerting, but how do you test and make sure that that is working as you expect? And also, how do you monitor all of your alerts? So it's an interesting thing we do, which is just looking at a single pane of glass across all of your applications by monitoring all of your alerts across 50 or 100 applications at once. And then review time for us is all around trends. You're looking in the last day, weeks, months, and looking at trends here. This is really around SLIs, SLOs, SLAs. And we've built something to integrate with Sumo, which we call a scorecard application, and I'll show you that too. And then release time monitoring, I feel, is one of the most important but yet neglected aspects of monitoring. This is saying that a lot of errors and issues are introduced during a release. And so you want to actually have some very good monitoring to look at the point of time when you're doing a release, compare the old state and the new state, so you've got the ability to roll forward or backward with little impact to the customer. So I'll show you how we do canary and targeted releasing, as well as how we monitor our releases with Sumo. So just look at releases here. What I've drawn up here is all of the channels that connect through to our banking APIs. So we've got maybe up to 100 channels. It's not just Macquarie channels connecting through to the banking APIs, but partners as well. So these are other companies that build their own mobile apps that will connect through to those APIs as well. And we also have the growth of more open APIs for banking. So you've got a lot of different channels to manage out there. And they go through an API gateway to our services at the back end. So all of those circles there represent services in Kubernetes applications. And if you look at it, you've got hundreds of services back there. But if you were to release a change to one of those services, what if that change, if I release one with this architecture, I could impact all of those channels? And what if I made a change and I impacted a partner who's built a mobile app we have no control over and we don't have the ability to test, and impacted them? And naturally what would happen is you would say, we can't release daily, we can't release frequently. You would end up having a release cadence of weekly and monthly. You'd end up spending a lot of time planning your releases because you're worried about the impact to all of those channels above. So for us to move to releasing frequently and daily, we needed to break that. So what we do in Kubernetes here is we group up those applications that make up what we call a product. In this case, this would be the accounts API. And we manage that whole grouping together. We take that grouping and we version that as a whole, as an environment. This is a version of the accounts API. When we do a release, even if we're changing one or two applications, we will deploy a whole new environment, a whole new namespace in Kubernetes. So you can see here I can release safely. There's no traffic pointing to version 1.6. Then we can do a canary release. So first we would use the API gateway. We would flick across our test accounts, run regression tests. If that passed, we would then start moving across a percentage of traffic on a particular channel, in this case the Macquarie e-banking channel. You can see here I've moved across 10% of traffic, and then we do monitoring, which I'll do a demo of with Sumo Logic. Once you've done that, you can then flick across the other traffic, say the mobile traffic, and do the same sort of canary release. But it's perfectly fine if something failed to run both production environments together in parallel simultaneously. For instance, I could do another release almost at the same time of a change for open APIs. And we could be running 3 production environments simultaneously. We also have the idea of lab and beta environments. So these are production environments, but not exposed to customers. It allows us to do a level of testing in production and then promote from lab to beta to production. And so that's how we do releases. And this sort of tooling we built to do these releases, and then it's offered to those 50 teams who are building the products. So, let me have a look. So this is just a demo, pre-recorded demo of release monitoring. At the very top, you're going to see a blue line. The blue line is all the traffic going to the current environment, the current namespace. What we'll do is dial up the traffic to the new environment, which will come up as an orange line right now. And the bottom 3 panels, looking at our monitoring of that, I can see latency anomaly detection spiking up, and I can see errors spiking up. And you see very quickly after detecting those errors, we can roll this release back. So you see in the top panel, we're now 100% back on blue. So we do this sort of release monitoring to then get confidence in the change, so that regardless of all the developers' work in doing quality all the way up to the release in production, this is just another level of confidence to make sure that that change isn't introducing errors or latency. So every release will use Sumo for this. Now for failure testing. So the idea of failure testing is that imagine if you've got your monitoring and alerting. What we used to do is after an incident, we would review our monitoring and alerting, and kind of reactively, we would say we have to improve our alerting, for instance. The incident maybe wasn't picked up well with our alerting, so we might go back and add more alerts. This is a very reactive approach. If we wanted to be proactive in how we manage our alerting and monitoring, we want to be able to simulate failures or inject failures into environments and assert that we expect under these failure conditions, we're going to have these alerts fired and this monitoring and dashboarding should show accordingly. And so that's kind of the idea around failure testing. So you should be able to inject failure at any level in your whole stack and then test that scenario. Now monitoring and alerting is one thing to look at. Probably even a more important thing is with failure testing is that you can now test what your user experience is like and the customer experience in failure scenarios. A very good example is if your profile photo was slow to load on your loading, say your banking app, that's not a very significant thing. So you don't want your whole app, your whole loading of the page to be affected by this profile photo not loading. And these are sort of things we can test to make sure the customer experience is still kind of resilient even if something like the photo is not. And so the way we do this testing now is with Istio. So if you're familiar with Istio Service Mesh, in Kubernetes now, you can pretty easily install Istio. What it does is it will proxy every one of your services. Every call going in and out of your application is proxied. And then Istio allows you to manage whatever you want on those proxies. It's a very powerful tool in general. What we can do with this is inject failure into any of those levels. So now we've got the capability to easily inject failure at any level. You can inject latency, you can inject errors. Even in this case, 10% of calls should return 500 on a particular service. The nice thing about this, if you run Kubernetes, is even we don't use Istio in production yet. But we've put this into non-production very easily. You've got no harm in putting this in non-production. So anyone who's running Kubernetes now can start doing this sort of failure testing. And this brings to something which we want to do, which is kind of moving towards a CICD for monitoring. So we're starting to look at our dashboarding and alerting. We want to move more of it into code in Git so that all of our dashboards alerts are in code. And when we change it, we deploy it to Sumo. So with the content management API. And I know that Terraform plugin is being worked on a lot more to enable you to do this more easily. And so if we do that, we could build alerts in code, make a change, we could deploy that to Sumo. We can then set up environments, test environments, inject failures, simulate load, and assert they're fired. So this would be the ultimate to get to, where all of your alerting is actually tested. So I'll show you a bit of a demo with some scripting of doing this. So in this demo, we're just going to create a new dashboard using the content management API. So at the top left, you'll see the dashboard pop up in the folder. Yeah. And this is a dashboard, just a very standard dashboard of showing your availability and latency on an environment. So we've already got traffic flowing through into this environment. So we'll just see in the different panels, availability is at the top, latency and slowness is at the bottom. The bottom right is showing alerts that are being fired. So what we want to do now with Istio is inject failure into that environment. So first we're going to inject 20% slowness into the application called Megatron. These are all demo applications, by the way. Nothing here I can show you is real, by the way, so everything's a demo environment. So I've injected some latency, and you'll see the latency anomaly detection at the bottom is spiked up. We've also got another panel showing alerts. So it just shows you the control you can have and how you could easily in any environment control your failure and then assert how it would look on your dashboards and alerts. So we'll just recover from those errors and bring it back to normal. So all of those environments were changed with Istio quite easily. Now everything should come back to normal. And then the next thing we want to do after this is inject failure into the environment. So this will be injecting HTTP errors into one of the services. So I'll just wait for that to come up. Everything's just normalizing again now. So we're just going to inject 20% 500 errors on any call to Megatron application. So we should also see now the availability spiking up, having issues. That could affect other applications too that are dependent on Megatron. In the bottom right, I can see the alerting firing, different type of alerting for these errors. So there's a lot of capability there with Istio and Kubernetes in order to do these different scenarios and testing. The next thing I want to talk to you about is monitoring of your alerts. And so because our feature product teams manage their own, they support their own applications. And so they're really focused on their own applications and what they do. If we want to get a single pane of glass across the 50 or 100 of applications, a nice way of doing it is by looking at your alerts, because your alerts are standardized, right? You've got a standard way of looking at the current operations of your systems. And so the other nice thing is that if you think about an alert, a developer has said this is something of interest. It's not noise. An alert by its nature in being triggered is something of interest. If it's not of interest, people will naturally turn it off. So monitoring your alerting is a very powerful thing. Now here's just a visualization to show you what I'm talking about. You can't do this visualization in Sumo yet. It would be great if you could. What I'm showing here is every single row is a system. I can see the top a blue system that's very noisy. It's firing a lot of alerts. You can see some other systems that don't fire often, but a few incidents are happening. And at the end here, I can see like more of a wider incident. And so in something as simple as that, it probably explains the concept of how powerful it can be in terms of end-to-end monitoring across multiple teams of your services. It would be great if we could visualize this one day in Sumo. But I will show you what we've got just very simply. So the same sort of view in Sumo. We just do it with the stack chart. So you can easily see the noises happening from one application. So we'd probably speak to them about if there's real incidents or if they're just noise. And then when an actual incident happens, we should be able to clearly see it spike up and see the applications that are impacted by the incident. It's a very, very simple view, but I just thought it's kind of a nice little thing anyone could implement. If you can get all of your alerts and the content of those alerts just as logs in Sumo. Oh, that's it. Now, I want to talk about what we do with review time, SLIs and SLOs. But before I do, let me just show the difference with runtime and review time, because I like to have this clear separation in what we're building between live monitoring and review time monitoring. So if we look at the same system here, looking at runtime monitoring is really about measuring ideally all of your applications, all the ingress points, their HTTP errors, failures, latency. If I was measuring all those points in green, I'd have a very good monitoring coverage. And ideally, if I did the egress points as well, this would be great. I've had a lot of data points here to look at everything happening right now, real time. But when you look at how those dashboards and alerts are managed by the development teams, it's a very system-centered perspective. If you talk to people about what's happening in the systems, they're going to give you the system names, which is great for them to respond to the incident. Everything here is about an incident happened, I want to detect it as quickly as possible and respond to it. What we want to do with our review time monitoring is take a customer perspective. So looking at everything we want to look at here is what's the impact to the customer. And that's the concept of looking at SLIs and SLOs. And so if I said there's a function such as fetch accounts, I could measure it at the top there, the top level API. I could say, here's my performance and latency and errors for fetch accounts. But fetching balances is a component of accounts. I can't measure it there. I have to work out what the best place to measure the performance of fetch balances. And that might be a few rows down. But really, I'm trying to look at the customer perspective here and pinpoint the exact spot I want to measure the customer perspective in using our application. And this is where we built an application called the Health Scorecard to scorecard all of our functions and applications. So this is where we have to manage our SLOs. So if you're not familiar, the SLIs are effectively that pinpoint of what I'm measuring, and they can map one-to-one to a Sumo query. So you're running a query in Sumo to measure something, you could say that's an SLI. The SLO is just a target on top of that SLI, where we can see if we're breaching our SLO or not. It's something of interest. If you're familiar with SRE practices, there's also error budgets, which we haven't implemented. And if you're familiar with SRE practices as well, it's pretty difficult to implement error budgets. But at the very least, we've got our SLIs and SLOs practices starting to happen. Our scorecard application, it's quite simple. So we're still building this more. I hope you can read it. But here again, this is demo data, but we've got broken up into functions from a customer perspective, things like get users, get accounts. We've condensed everything down into a star rating just because it's very simple to go to the various development teams that own this and to say that actually we've got a problem. We also have the key metrics of availability and latency, and they're going red where they're breaching SLOs. And this could be a period over a 1-week period or a 2-week period. So we're always looking at longer term trends here. And the idea of this is to go to those development teams and speak to them about how they can improve their resiliency and what their impact is to the customer. Because that's how you can really drive from the product business perspective more of your resources in improving your resiliency. We do also capture the same level of information on the system level. So it's just the same thing for system. And we do try to measure what we call, incidents. Rather than looking only at our ticketing system, we try to kind of automatically say what is an incident or not objectively by looking at large spikes in, say, 500 errors. If you had a large spike in errors over a period, we'd say that's an incident. It's kind of nicer that we measure it objectively as opposed to just looking at tickets. And we do things like looking at the top 5 of things, top 5 slowest, least available, etc. And all of this is to drive the resourcing into the right area to improve the resiliency for the customer. So that's actually the end of my presentation. So I think we're open for some questions right now.
Questions on the session?
So I had a question about the alerts that you're injecting. So how do you understand what a realistic alert or error looks like when you're injecting those errors and testing those out? Is that on an infrastructure level or for an application? And
Yeah, so all of the errors injected by nature of it being Istio is the application level. HTTP, you could inject basically HTTP errors and latency. There's probably 2 aspects of this. One is if incidents are happening or have happened as a review process, you could then try to simulate that exact same incident again, which is always good to retest. And then there's maybe theoretical cases of what happens when this is down or slow. We've had cases where you would look at, let's say a database was running at a lower redundancy for a short period, and people question what happens if that database went down, what would the impact be? That was a very good use case where we said, when that database is down, how is it going to actually impact all of our applications and the customer experience? And then we could simulate that and test that.
I'm curious what do you have a process? So you have alerting on number of 500 errors. Do you ever have a process for handling like non-error results that are incorrect? Is that something you guys try to track? Like it returns the wrong result, but it's still like an okay response.
I know what you mean. It's a difficult one to track, so it's not something we really look at. I mean, aside from if you're adhering to HTTP as much as possible, you'd measure it there. Then you've got kind of exceptions in the code and other log lines of interest, which I didn't really cover here, but every application would be alerting on anything it wants of interest. Not maybe specifically your case of HTTP 200 with an incorrect response. You'd have to detect it somehow and then log it out.
Hey, so the question is, I see that you have that dashboard with the real-time alerting showing alerts firing across multiple applications at the same time as a way to test like a release, right? Were you able to achieve that because you're setting up your alerting at the code level so that these alerts actually firing individual log messages? Because normally when we set up alerts in Sumo Logic, it's like we're taking logs and translating them into some kind of alert, and it's very difficult to bunch up a lot of different alerts into one single visualization, right? So basically, is it a requirement to basically set up your alerting at the code level so that you're just logging alerts?
Yeah, so the answer to that is no, because it would be hard to do it at every application level. And so what we do is our actual kind of paging system is using Facebook for Workplace. We use it in very interesting ways with chat rooms and everything. I don't think many companies use it for that. And what we do is, so we're funneling into the paging system our alerts. So what we do is we take it from a Sumo alert, right? And then we'll pick that up, we'll alert it into a scheduled view or a query, and then we'll pick that up in one central place where we forward it to the paging system. So that central place is where we would log everything. So the Sumo alert doesn't go directly, it goes through a funnel. One of the other reasons to do the funnel is that you want to be able to enrich your alerts with more metadata. And so if you've got an application that it only has information that's inside that application in the alert, but we have more metadata about who owns the application, the team responsible, etc. And so on the way through, we enrich it and then put it through to the paging system. And that's when we can log it.
Fortunately, we are out of time for more questions, but you can talk to him offline. And thank you, Jason. That was a really great session.
All right, thank you.